Okay, so, sorry, let's do binomial expansion for SL. First thing we want to do is review a topic, combinations. So if you recall from the beginning of the year, when we did a topic with the higher level kids, we wanted this idea of combination. So the question is, how many ways can we choose K items? Let's make it R, sorry. R items from N. So for example, and we saw the notation was NCR, or we saw like the N and R in like these funny brackets. And the idea and the formula was N factorial over R factorial times N minus R factorial. You did problems like this. And the question was, for example, you have like a kid is for choice, and you tell the kid you can choose two of them. Choose two. And so, let's call the choice A, B, C, D. So we have A, B, A, C, A, D. Let's call the choice A, B, C, D. And so you choose two. So there's A, B, A, C, A, D, B, C, B, D, and C, D. We have 6 ways. So if you have 4 choice, choose 2. You have 6 ways to do that. How does the formula work? 4 choose 2. So we have 4 factorial over 2 factorial times 4 minus 2 factorial, which is 4 times 3 times 2 times 1, 2 times 1, 2 times 1. We get 6. And this is the idea of combinations or choosing. Okay, let's put that off to the, how do we do that? Good. Let's put that off to the side for a second. So N choose R is this formula. It's from N, choose R things. Good. Now I'm erasing. Okay. Now, the lesson is binomial expansion. Maybe you did it last year, maybe you didn't. That's okay. The idea is we want to be able to expand a binomial to the nth power. Now, we could go old school. So, for example, if I say, I'm going to be asking you, I'm going to ask you, is there a fast way to do this? The answer is yes. So, let's build up to it. So, first of all, I'm going to ask you to do x plus 1 to the 0. You say it's 1, Mr. Adler. X plus 1 to the first, it's x plus 1. X plus 1 squared. Well, we know it's x plus 1 times x plus 1. Maybe you did the FOIL method last year. You say x squared, x 1, x squared plus 2x plus 1. Let's go a little further. X plus 1 to the 3rd power. Now, instead of doing the FOIL method, let's do a different approach. So we're going to do the box method. Along the top, I'm going to put, since I know x plus 1 to the 3rd is actually x plus 1 squared times x plus 1, I'm going to do the FOIL method, but the same way. So it's x squared plus 2x plus 1, and along the side it's x plus 1. And so same thing, x cubed plus 2x squared plus x squared plus 2x plus 1, and we get x plus 1 plus 3 is equal to x cubed plus 3x squared plus 3x plus 1. Obviously, I'm not going to make you do this. We're just developing an idea. Let's try x plus 1 to the 4th. Well, you could say, you know what, Mr. Adler? X plus 1 to the 4th is actually x plus 1 to the 3rd, right, times x plus 1. Do it again. Let's see, x to the 4th, 3x cubed, 3x squared, x to the 3rd, 3x squared, 3x 1. And so you get x to the 4th plus 4x cubed plus 6x plus 4x, this first term, plus 1. I can make it do the 5th power. You can try it on your own, and what you'll discover, if you do it on your own, you will discover that x plus 1 to the 5th power is equal to, try it on your own. Okay, we're back. X to the 5th plus 5x squared plus 10x, I'm sorry, 5x to the 5th plus 5x to the 4th plus 10x to the 3rd plus 10x squared plus 5x plus 1. So you say, Mr. Adler, why did you make us do all that? If you're saying we don't have to do it again. Okay, well, the first thing I want you to notice is that a couple of things. Well, the first thing you notice is that the axis seems to be going down. Okay. And so as the exponents, so we're going to see that the exponents are going down, and then good. Now, the next thing you notice, I'm going to show you, is that you might have learned something called Pascal's triangle. And so if we take all the coefficients off, something interesting happens. So I'm going to mark the coefficients. Here's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And then the last row is 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. This is the beginning of what is known as Pascal's triangle. Pascal's triangle. And Pascal's triangle has a lot of amazing, characteristics and really interesting things. For example, you might notice that, 2 is 1 plus 1, or 4 is 3 plus 1, or 10 is 4 plus 6. So if you add the 2 rows above, that gives you the entry below. Another really interesting thing about Pascal's triangle is if you add the numbers across, you get a power of 2, right? 1 is 2 to the 0. 1 plus 1 is 2. 2 to the first. 1 plus 2 plus 1 is 4. 2 squared. 6 plus 7, 8. That's 2 to the third. 10, 11, 12, 16. That's 2 to the fourth. Let's see, 20, 30, 32. 2 to the fifth. It's kind of cool. And there's tons of stuff, tons of things. Anyway, so what do we need Pascal's triangle for? Well, Pascal's triangle helps us, expand these binomials really quickly. And so here's the old school trick, right? So when I say x plus 3 to the 5th, you say, okay, I know that because there's a 5, there's going to be 6 terms, right? Because when we raised something to the first power, there was 2 terms. When we did, binomial times binomial, we got 3 terms. So I know there's 6 terms. So that means I need to go to the 6th row of Pascal's triangle. So I know I'm going to be using 1, 5, 10, 10, 5, 1. Let's see what's going on down here. Now, what I noticed is that the powers of x were going down. What you didn't see is that the powers of 1 were going up. So an old school way, what you're going to do is you're going to say, fine, x to the 5th, 3 to the 0. X to the 4th, 3 to the 1st. X to the 3rd, 3 squared. X squared, 3 cubed. X to the 1st, 3 to the 4th. X to the 0, 3 to the 5th. Okay? Because remember, it's going to be a sum of terms. Then you're going to put on the coefficients, which are going to be from Pascal's triangle. 1, 5, 10, 10, 5, 1. Remember, we're adding all these together. okay? And now we have to simplify it. So let's see, 1 times 1, x to the 5th. 5 times 3 is 15. 10 times 9 is 90. 10 times 27 is 270. 5 times 81 is 405. And 3 to the 5th is 243. And what you've just done is you've expanded a binomial. Without going through all of this, you quickly expanded it out. Let's try another example. Obviously, you have to pay attention to each of the terms, and you have to pay attention if you have negatives or positives. Let's expand 2x minus 1 to the 4th. 2x minus 1 to the 4th. So you say, okay, no big deal. I know that it's to the 4th power, so there's 5 terms. You go to Pascal's triangle and find the row with 5 terms. 1, 4, 6, 4, 1. That's my coefficients. Maybe you might want to write it down. 1, 4, 6, 4, 1. And that I need to know what the terms are. So I know that 2x starts at 4 and descends, while negative 1 starts at 0 and ascends, right? So we have 2x to the 4th, negative 1 to the 0, plus 4 times 2x to the 3rd, negative 1 to the 1st, plus 2x squared, negative 1 squared, plus 2x to the 1st, negative 1 to the 3rd, plus 2x to the 0, negative 1 to the 4th. The pattern holds. Remember, we have the Pascal's triangle coefficients. The 2x starts at 4 and goes down to 0. At the same time, negative 1 starts at 0 and ascends to 4. Now, let's clean this up. So let's see. 2x to the 4th is 16x to the 4th plus, well, but it's not plus. Negative 1 times 4 times 8 is negative 32x to the 3rd. Let's see what's going on here. Plus or minus? Well, negative 1 squared is positive. So we have plus 24x squared. Negative 1 cubed is going to be negative minus 8x. And last one, plus 1. Little trick. When you have a minus here, you're going to have it's going to be oscillating from negative to positive, negative to positive. And once again, we've expanded a binomial to the 4th power just by quickly using Pascal's triangle. You can make up your examples. Now, IB doesn't ask you to expand it anymore. No. So what they're going to ask is for a specific term. Now, so you say, well, good. Now, the problem is, some of you might say, oh, I don't get it. I'm going to look at the formula booklet. And the formula booklet gives you a weird formula. And they write, the formula booklet looks weird. It looks something like this. They say A plus B to the n is equal to B to the n, plus NC R minus 1, A to the, N minus 1, R to the 1, and they give you these weird combinations. So the question is, where do the combinations come? If you look at the formula book. So look at the formula booklet. And you say, what do combinations have to do with it? Well, kind of something interesting. It turns out that all of these terms are actually combinations. Let's think about it. How many ways are there from nothing to choose nothing. 0, choose 0. Well, that's 1. If you have one thing, how many ways can I not choose something? 1. If I have one object, how many ways can I choose one object? Well, that's 1 also. Not a coincidence. Let's go to the third row. If I have 2 things, how many ways can I not choose any of them? Well, 1. If I have 2 objects, how many ways can I choose one of them? Well, I can choose A or I can choose B. And if I have 2 objects, how many ways can I choose both of them? Well, there's only one way to take both of them. Let's try the third row. 3, choose 0. I have 3 objects. How many ways can I not choose any of them? 1. If I have 3 objects, how many ways can I choose one of them? 3. I can choose A, B, or C. What about if I have 3 objects and I want to choose 2 of them? AB, AC, BD, AB, AC, BC, 3. And 3, choose 3, 1. So it's kind of cool that Pascal's triangle is actually the combination of n choose r. So if I said, what is 5 choose 3? Find 5 choose 3. You would say, okay, Mr. Adler, 0, 1, 2, 3, 4, 5, 5, 0, 5, 1, 5, 2, 5, 3. Once you have Pascal's triangle down, you can once again, you can always use the formula, but Pascal's triangle is really cool. So this is kind of interesting. Now, why do I bring this up? Because IB is not going to ask you to expand it out. What IB is going to do is they're going to say, they're going to say, find a specific term of an expansion. Find a specific term of an expansion. They will say, find the x to the third term of 2x plus 1 to the fifth. And this is going to be like a 4-point question, so you don't have that much time. You got to get it down. So the question is the x to the third term of 2x plus 1 to the fifth. Here's the Adler method. Okay, you know that every single term is 5 choose something, right? Because it's 5. That's where remember, that was the row of Pascal's triangle. It's 5 choose something. You know it's 2 to the x to the something, 1 to the something. You know that it started out with 5 and went down to 0, and 1 started at 5 and will go up to 0. Now, they tell us what term we're looking for. So you say, okay, if we're looking for the third term here. Now, the question is, something I didn't bring up, what's the term there? Well, if you go back, I want you to add up the exponents of the 2 terms. And you will discover that the sum of the exponents is always 5. That means this is 2. Now, here's the Adler trick. It turns out that this 2 is the 2 here. And you're done. So let's see, 5 choose 2, that's 10. 8x cubed times 1, therefore 80x cubed. Let's try another one. Let's see. So find the x squared term of, x minus 5 to the 6th. Same idea. I don't want to write the whole expansion out, so I know that each term is 6 choose something, x to the something, negative 5 to the something. I'm looking for the x squared term. So 2 up here, that means the sum of the exponents, this is 4, and the 4 goes here. 6 choose 4. Well, I can throw another level on Pascal's triangle down, Or I can use, so for example, if you have Pascal's triangle written down, I'm lazy, so I'm going to be like 1, 6, 15, 20, 15, 6, 1, 6, 2, 0, 1, 2, 3, 4. I know it's 15. I know that 6 choose 4 is 15. Or you can use the formula 6 factorial over 4 factorial times 2 factorial. 6 times 5 times 4 times 3 times 2 times 1. 4 times 3 times 2 times 1, or 2 times 1. This goes out with that. This goes out with that. 15. So, final answer, 15. X squared, 625. Hey Siri, 625 times 15.
625 times 15 is 9,375.
And that's how you do that. It doesn't get advanced. I'll give you an advanced problem if you want. Well, no, we're going to stop there. If they ask for the constants, so they might say if they ask for the constant term, then x is raised to the 0. And that's basically it. So for example, if they say, I don't know, 1 minus 5x to the 4th power, fine. Well, no, let's change it to 2. And they want the constant term. You say, okay, for choose something to negative 5x. We know this is 0, this is 4, this is 0, this is 1 times 16 times 1. The answer is 16. That's basically it. Okay.